myself and Arun from Excellence College of Technology in the Department of EC. In this video, we are going to see about PA compensation techniques in control systems. PA is referred as proportional integrative controllers. So the main purpose of proportional integrative controllers are used in control systems are the values of errors can be rectified by using a proper resolution techniques. So let us see how the PA compensation techniques has been involved in control systems. So normally the control system functions are based on some are error signals and transfer functions and feedback signals. If you are giving input to the corresponding signals, then if it is having any errors, it just shows that okay, yes, as a steady state errors, so that we can able to identify the errors in the summer signals. If we don't have any errors, then automatically it just pass to the information as a destination in. If it is having error, then feedback loop is processed and get an error, and the error has been rectified. After that, it can move to the transfer function of the systems. So that here the P controllers and PA controllers are very useful to identify that errors to reach the transfer function of the systems. It can be captured in this medium of the in between input signal and transfer function of the systems. It is known as steady state error, stability and steady state error of the corresponding systems. Root locus. The root locus is marked by using a root. The example of this system is s cube plus 3s square plus 2s plus k equal to 0. In this control system, the root is 3. So the value of 3 can be marked and it can be identified as a stability of the system by using a following graph. So in this x-axis, y-axis, it can be able to mark real axis and imaginary axis. Initially, we have to identify which kind of information is to be followed by using this expression, whether it is marked as a imaginary axis or real axis. We have to check the corresponding equation as of propagative proportional integral formulas. So after getting a gain value of the product, we can mark it easily in this graph, so that we can able to catch the corresponding value of the gain. Steady state errors. Once we have received the error from the transfer functions, is just follow the type 0, type 1, type 2 systems. Initially, we have to follow by using a proportional velocity and acceleration errors. Once it just resolved all those errors, then automatically we can get the original signal. It has to mark it in this root locus formula. So after getting the final answers of the gain value, we can mark it as easily. Initially, the gain value k equal to 0.2. Then the steady state response of the corresponding equations can be plotted. It can be plotted based on real axis and imaginary axis, based on the values of the corresponding equations. So here we get the values are minus 2.008, minus 0.709, minus 0.12. So initially it can be marked in this minus value, because already we have received only the information as minus value, so that the graph will be improved towards the 0 value. Finally, we can conclude the equation with the help of the transfer function by gain margin and phase margin. After getting all the data by using the transfer function, we can able to map the corresponding root locus. By using a root locus, we can get the concerned gain margin and phase margin with the help of graph. So from that k equal to 1, if it is cross the value k equal to 1, then the system is said to be a damped or undamped or overdamped. Based on the criterion, we can able to find the concern stability factor by using the gain margin value. So base same value, that if it is k equal to 5.8, and automatically just improve the highest value. After that, it just move towards the zero value. So like that, all the values has to be plotted by using the corresponding gain and margin values. Advantages. Through the PA controller, we are adding more number of poles to the circuits or zero value in margin, so that we can have a lot of marginal value in the gain margin. As the pole in the origin is affected with the more number of information, hence the PA controllers may reduce the stability. Assessment. So from this, we can able to know that how the PA controller has been performed in the block diagram. So here initially it may be followed by summary expression. The errors can be generated with the help of this feedback signal only in the form of proportional or integral or derivative controller errors. These errors has to be mapped with the help of integral proportional controllers. Based on the error value, it can be mapped and it can be analyzed with the help of derivative process. After that, it can get the original signal and it can be passed towards the other operations. Thank you.